Right, welcome back, and I need to continue talking to you about this little terminologies here and there around motion, and one of those is what we call acceleration. Now, acceleration is the rate at which velocity changes, so we would mathematically define it that way. A equals change in v over change in t. Now obviously v must be changing from one value to another, so the change there should be given by v final minus v initial, and of course divided by the time taken for that change to occur. Acceleration, we need to know, is a vector quantity. This tells us that when we talk acceleration, we need to be wary of the fact that we express it in both magnitude and direction. Okay, now acceleration of an object can result in either a speeding up of an object or slowing down. Some people believe that or think that when something is slowing down, we can say it decelerates. Well, everyday language we accept that, but scientifically we don't accept the word deceleration. So even if the acceleration is such that it's slowing down an object, we just say the acceleration is in the negative direction, or is in the opposite direction of motion. For example, quickly let's have a look at this. An airplane moving from rest, so initial velocity is 0 meters per second, takes 18 seconds to reach a speed of 68 meters per second. What is the acceleration of the plane? Acceleration is v final minus v initial divided by the time taken for that change. So it started from 0 to 68 meters per second. So this is 68 minus 0 divided by how long it took for that change to occur, 18 seconds. So you have got a situation where you have 68 divided by 18, and this should give us 3.78 meters per square second. That is the unit of measurement for acceleration, meters per square second. And of course, in the direction of motion, because this is a vector quantity, we need to specify the direction, in the direction of motion of the plane. Okay, now quickly, let's talk momentum here. Momentum is the product of mass and velocity. When we talk product, we mean that whatever we're working on here, things are multiplying each other. Product is an answer we get when we multiply. So mass multiplies velocity to give us momentum. Momentum is symbolized by small letter p. So p equals mass times velocity. This is your mathematical definition of momentum. Okay, now the unit of measurement here for momentum is kilogram meters per second, following from the fact that here we're saying momentum is mass times velocity, mass in kilograms, velocity in meters per second. So you multiply that together, you must get kilograms meters per second as the unit of measurement for momentum. Now momentum as well, just like acceleration and velocity, is a vector quantity, and therefore we need to express it in both magnitude and direction. So we need to be wary of the direction of motion every time we talk momentum, every time we talk acceleration, and every time we talk velocity. Okay, an example here, an athlete 65 kilograms running at 2.5 meters per second towards the east. What is the momentum of the athlete? P is mass times velocity. That should then be equal to 65 times 2.5 meters per second, and we can quickly get that 65 times 2.5 seconds, and the answer becomes 162.5 kilograms meters per second. Okay, that is the momentum of the object. Now change in momentum. Momentum can change, okay? The change in momentum of an object is found by then subtracting the initial momentum of the object from the final momentum. Let's have a look at it. This delta P would mean change in momentum. It should be equal to momentum final minus momentum initial. Momentum final should be given by the mass of the object times the final velocity of the object, and the momentum initial should be given by mass of the object times the initial velocity of the object. So if you look at this, because we're looking at the same object, this m here can be factorized out mathematically. So we have m into v final minus v initial. Okay, let's have a look at an example here. A car of mass 1,400 kilograms is traveling at 72 kilometers per hour along a straight road. The driver applies brakes and slowed down the car to a velocity of 20 kilometers per hour. Determine, so we'll see what to do. But quickly, let's convert this. 72 kilometers per hour into meters per second. We divide by 3.6, okay? 72 divided by 3.6. So we get that to be 20 meters per second. And then 20 kilometers per hour divided by 3.6. What is the answer here? The answer is 5.56 meters per second. Okay, now let's answer the questions. What is the initial momentum of the car? P initial should be equal to mass times V initial. That should be equal to 1,400 times what was the initial momentum, velocity, 20, okay, meters per second. So you've got 1,400 times 20, and that gives you 28,000 kilograms meters per second, okay? And final momentum can do that. We're going to start from here in our next section, and then we see how we end up finding the change in momentum. See you then.